Okay, here we have a question. We start with 12 bags of flour, their weights. We've got some reading to do. Will be important, some of that reading. But we get into part one and we realise that we need a confidence interval, which is going to be a recipe with an X bar in it, a Z, a sigma, or if you can't find a sigma, use an S, and an N. So you've learned a recipe with those four things in it. So quote it and apply it. Your X bar is going to come from the data. Your Z is going to come from a picture of a normal distribution and this 98%. N should be very easy. You've got to always have a decision, S or sigma. Use sigma if you've got it. In other words, use the population standard deviation it's given. Only as a last resort do you use S, the standard deviation from the sample. So see which of those you've got. Knowing that recipe is strongly recommended because it leads to 5 pretty easy marks in this question. A couple of 1 markers as a follow-up, and this is where you need to know your theory and try and suss out what the question's getting at. We've got to explain why, or to state why, we didn't need the central limit theorem. It's not necessary. So it's about when you're allowed to use the confidence interval recipe. It's based on an X bar, that's the hint. X bar has to have a normal distribution for the recipe to be valid. Now the central limit theorem is one reason why X bar might be approximately normal, but there's another reason you can use. Somewhere up here there are some keywords that you can focus in on that give you permission to take X bar to be normal even without the central limit theorem applying. So go and look for those words. Even if you didn't find them, there's another chance if you understand the wording in part 3, because this wording is saying what's the minimum number of weights we would consider necessary for the method to be valid if you didn't know the distribution of weights of bags of the flour. So this is where the central limit theorem does come in. The answer is just going to be the minimum number your teacher has told you. But the clue to the previous part is that the central limit theorem would have been needed if we didn't know the distribution of weights of bags in the flour. So that's a very strong hint to this previous part. Anyway, part B is in any case a re-entry point. So let's have a look at that one. The bags say 1 kilogram printed on each one. And this is a very common thing. They want us both to use the confidence interval and use the weights of the given sample. In other words, we're looking at individual weights of bags to make a comment, and we're using the confidence interval to make a comment. And they talk about different things. The weights of individual bags lead you to comment on, is 1 kilogram a reliable claim for every single bag, and looking at those numbers you can explain whether or not you think that's true. But the confidence interval is not to do with weights of individual bags, it's to do with the mean weight mu. So if this 1 kilogram is taken to refer to the mean weight, you can use your confidence interval to decide whether that's a plausible claim about the mean. So 2 separate comments, one based on the mean and your confidence interval, and the other based on individual bags which come from the sample data. Very common that in a confidence interval question, to be asked to do both those things. And then finally, just another 1 marker, again testing your understanding of what a confidence interval is. If we happen to know that the mean is 1,000, the population mean, and there's someone going out calculating a 98% confidence interval, what's the probability they won't catch the mean, the 1,000, in that confidence interval? So what are their chances of failing to get the mean in their 98% confidence interval? And it's just direct use of that 98% together with understanding of what the question's asking.